So welcome to this segment. I want to show you how to construct ionic equation. So when you're constructing ionic equation, there are things that we call spectator ions, ions that do not take part in a chemical reaction. So you're going to see them as I demonstrate. So now when you're writing or constructing an ionic equation, like the question says, write ionic equations for the reactions below. What we do, if you have solid, liquid, gas, and you have something in aqueous, you split up those that are, so you split up only those that are in aqueous. If it is in gaseous form, we do not split. Liquid form, we do not split. Gaseous form, we do not split. We just leave them the way they are. But anything that is in aqueous, you need to actually split it up into its respective ions. That's what I mean in this case. All right, so you need to remember when you split up a substance, for example, if I have a substance such as maybe, copper carbonate. So copper carbonate here, for the formula to be like that, it simply means that the copper had a valence of 2. So when I split it up, it simply means that I'll give it, the valence as well as the charge. The first part carries always a positive charge, then the latter part carries a negative charge. Then the carbonate, as we know from your valences, carbonates have a valence of 2, but you also give it a charge. And if you leave out those, charges, it simply means what you are writing is actually wrong, because that's the essence of ionic equation. We want to show the ions that they have. So how do you get the ion? You first of all write the valence. Is it in valence 1, valence 2, valence 3, valence 4, and give it the charge that it has. But of course, like I told you, the first part in a chemical compound is always positive, and the last part is always what? Negative. So just give it the valence and attach the charge it has. Remember, only split those that are in aqueous. Solid, liquid, gas, please leave them alone. Just keep on writing. So let me show you quickly how you can do that. For example, sodium chloride in aqueous reacting with hydrochloric acid in aqueous to produce sodium chloride and water. So this I'll split, but the water, because it's in liquid form, I'll just leave it the way it is. So when we split now, it is going to be sodium has a valence of 1, so I'll just write a positive. I'll use a slash to show that they have separated. This OH is an hydroxide, a radical, which carries a negative charge, and these are still in aqueous. Plus, when I look at that one, there's hydrogen, which carries a positive charge. It has a valence of 1, 2. Chlorine, found in group 7, also has a valence of 1, and that is still in aqueous. What are they producing? That one in aqueous will split. Sodium is in group 1, therefore it has a valence of 1 and carries a positive charge. Chlorine, in this case, negative, and that is in aqueous. Remember what we said, anything solid, liquid, gas, do not touch them, just continue writing them the way they are. Now once you split up, you split up the ions that are soluble, you need to cancel out what we call spectator ions. What exactly are spectator ions? These are ions that do not take part in a chemical reaction, and you can see them on both the left hand side and the right hand side, and they appear the same. For example, if I look at sodium Na+, I have Na+, so this and that will cancel. Another thing that is a spectator ion, you can see chlorine, Cl-, so this and that will cancel. So if you notice, what have I remained with here? I've only remained with this sodium Na+. Don't forget the charge, it is still in aqueous. Plus, here I've only remained with the sodium has actually been cancelled out. Sorry, we have actually cancelled. What we are remaining with here is simply hydroxide minus, that is still in aqueous. Then there we are remaining with hydrogen ion, that is still in aqueous. To produce, what we are remaining there is H2O in liquid form, and this is what we call as being an ionic equation. So these, an ionic equation just tells you the ions that were taking part. So it's like hydroxide ion was reacting with hydrogen ion to produce just water. So that is our ionic equation. Let's look at another one that we we do have, I'll call it B. Let's say that zinc is reacting with hydrochloric acid, which is in aqueous. Zinc is a metal, therefore it will be in solid form, and that is going to be zinc chloride. That's the correct formula, plus hydrogen. Zinc chloride is in aqueous, hydrogen is simply in gaseous form. Let's try to write the ionic equation. Are you going to split this? No, you leave it. Remember what I said, anything in solid, leave it the way it is. Plus, we need to balance up this equation, so we just need to put up a 2. That's the first thing. If the equation is not balanced, ensure that it is actually balanced. Now remember, we are going to split up this hydrochloric acid, but there's a 2. This 2 multiplies with the elements inside, so it will be 2 hydrogen, which carries a positive slash. This 2 multiplies with the chlorine, so it will be 2 Cl minus, and that is still in aqueous. Okay, that is going to be split up, so we are going to have zinc, Zn. Zinc has a valence of 2 but a positive charge there. Now when the like Cl2, when you have a subscript there, when you split it up, these 2 should be brought in front, so it will come 2, then you write Cl and give it the charge that it carries, which is a negative. Then that is going to be, that is in gaseous form, so leave it alone. We're not going to split it up. The next thing, you cancel out what we call spectator ions. They will appear the same on the left and on the right hand side. So what are the spectator ions that you're able to see? I can see 2Cl minus, this will go, and 2Cl minus, it will go. Is there anything else that we have? The answer is no. And therefore, what we are going to do is we are going to rewrite without the spectator ions to get the ionic equation. So here I do have zinc, which is in solid form, plus there I have 2 hydrogen ions, which are in aqueous, to produce zinc, 2 plus ions, which are in aqueous, plus hydrogen, and this is in gaseous form. This is what we are calling as being an ionic equation. So that is the way you can go about it. Let me try to do maybe a last one so that you are able to see how you can also go about that. Like I said, patience is very important, and you need to ensure that you practice such things. It is simply going to help you. All right, so let's say that we do have barium chloride. Let me say I have barium chloride. This barium chloride is in aqueous. It is reacting with magnesium sulfate. So it is reacting with magnesium sulfate, which is in aqueous, to form, in this case, barium sulfate, which is in solid form, and magnesium chloride. And that magnesium chloride is in aqueous form. So the question is the equation in this case balanced? If I look at it, chlorine, 2 chlorine, 2 chlorine, 1 magnesium, 1 magnesium, 1 barium, 1 barium, the sulfate, SO4, so it's actually balanced up. So let's try to split up those that are soluble, ions that are soluble. So when you split up there, I'm going to have Ba. Barium has a valence of 2, so it will be 2, and it will carry a positive. Remember what I said, if it's at the bottom, take it in front, so that 2 come in front of the chlorine, and chlorine has a valence of 1, so I'll give it just a negative. This is still in aqueous. Plus here again magnesium, so you have got magnesium. Magnesium has a valence of 2 and a positive. Then there sulfate is a radical, it goes together, SO4, you give it a 2 minus, and that is still in aqueous. All right, that which is in solid, we don't touch it, so we are just going to write it the way it is, barium sulfate in solid form. There I'm going to split up my magnesium, which is a 2 plus. Remember that chlorine, the 2 come in front, Cl2, and the negative, that is still in aqueous. The next thing, you cancel out the spectator ions, those ions that are not taking part in the reaction. They are found on the left and the right hand side, and they look exactly the same. For example, I've got 2Cl minus, 2Cl minus, so the chlorine and the chlorine ion will cancel. I have Mg magnesium 2+ and Mg, so this and that will cancel. So you rewrite your equation without these spectator ions. That gives you your ionic equation. So here I've remained with Ba 2+. Most of the pupils make a mistake because they start forgetting writing these, charges, those ions. They are very important. Those charges is what makes it to be an ionic equation. Here it is SO4 2-, that is still in aqueous, and that is going to produce barium sulfate, which is in solid form. So it's like barium ions, we are reacting with sulfate ions to produce, in this case, barium sulfate. So this is what we call as being an ionic equation. So with practice, you indeed get to understand this. Please watch out for some more videos in both, chemistry, physics, biology, and also mathematics, so that you can learn more. If you like what I do, you can subscribe, and you can, share the videos or hit that like button. Thank you so much for watching.